Hi there, this is Jacob Nash, Precalculus Lessons, and this is Unit 4, Lesson 5 on reference triangles. Sorry about that, I got the wrong intro, but still that was the same song. Haven't had the intro kind of in a while. It's harder to have it when I have to record on my computer. But what are reference triangles? Well, you might think you've been spared from trigonometry so far this unit, but unfortunately, this is where it starts, and I hate trigonometry kind of. I like the more algebra part than geometry part of this course, but the first Jacob Nash videos I made, even that I ever made, were geometry anyways. But so maybe if you don't understand geometry, I mean some of the things I'm talking about, go over to J and Geo, Jacob Nash Geometry Lessons, and find that, and you'll find that I sounded different on there. It's one thing, but so what is a reference triangle? Well, it's just something that we can use to find certain sides and angle measures. And that's what we can do on a graph, in terms of a graph. So when you are drawing it, you make the hypotenuse reach out from the origin, and you draw the vertical up down to the axis. Vertical side is what it's supposed to say, but sorry if you don't understand that right now, but I can try to draw it on here. Hopefully it's not delayed today. Sometimes that happens, but basically, if you have your axes right here, you would draw your radius or hypotenuse. They would be the same thing for this, which remember is the longest side. Let's say it was in this quadrant, so you would draw that out right there, and then to draw a vertical side up or down to the x-axis, always to the x. Some people might think, oh, well, that's not what you ever do. You never draw it to the y-axis. And then your third side would just be on the x-axis. So a triangle would look like that in that quadrant. It could also look like this. It could also look like this. Obviously, those aren't even, and then like that. So they'll always look like that. So if you want to think, like, if you were to draw all the triangles, they should look like a butterfly. If it doesn't, then that means you've drawn your triangle wrong. Kind of, that might be helpful. But remember Pythagorean theorem, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. And remember, c is the hypotenuse, also r, which is the radius. If we were to make this a circle, when we get to the unit circle part, then we could use that. So that's what we would need to use to find a side we don't know, and that's what we'll have to do later on. So here are your trigonometry functions, and you might now see, oh, what the heck? Those are ones I don't know. Well, yeah, some of them are new, but if you remember SOHCAHTOA, that saying can help you know what sine of an angle, cosine of an angle, and tangent of an angle equal. And so OH, that opposite over hypotenuse, just keep in mind in case you forgot, hang on, it's too big of a size. O is opposite. A is adjacent, and in case you don't remember what these mean, we'll look at this later. Or really just in a second. And H is hypotenuse. And hopefully you remember that's the one across from the right angle, and it's the longest one always. So that's sine, cosine, and tangent. But what about there's inverses? And what is an inverse? Well, remember our inverse or rational function, it was 1 over x. So when you have something inverse, you take the numerator and denominator and flip them. That's what we do when we're trying to divide by fractions, right? If we're trying to do 3 divided by 2/3, you can just say 3 times 3 over 2. So the inverses mean That's not, don't get that confused with the sine to the -1, which we'll have to use. That's not what that is. We're talking about just flipping it over. So notice that sine over here, now we have h over o, we have h over a, and a over o. So sokatoa or choshakao, but that's not as good of a one because if you notice there's two C's, so you might get mixed up. But you can always just remember the opposites. You just change this, this, and this, and just make them different. But what these are is CSC is cosecant. Cosine is the inverse of cosine is secant, and the inverse of tangent is cotangent. So if you notice, don't get these two mixed up because you might think, oh, cosecant, cosine, secant, sine. Well, for some reason, whatever person made this was dumb and decided to make it like that. So those are opposite of what you might think, but that's just what it's like. At least cotangent seems easy to remember. So we'll be using that. And you need to know where the functions are positive. So this basically means when you take the whatever it happens to be, sine, cosine, or tangent of an angle, will it be positive or negative in what quadrant? Kind of like that. And something you can use to remember that is ASTC. All students take calculus, and they tell you what order the quadrants are. So hopefully by now you know your quadrants, but if you don't remember which ones are which, remember 1, 2, 3, 4, they are made in the shape of a C. So quadrant 1, and quadrant 1, all of them are positive, no matter what. That kind of makes sense because coordinates of anything in that quadrant is positive anyways. For quadrant 2, sine is positive. That also means cosecant is too, because that's its inverse. In quadrant 3, tangent is positive and also cotangent. And then in quadrant 4, cosine and secant are positive. Remember, secant, we've drawn secant lines before, remember that? We'll learn more about these things later. So now we're doing practice. Now that we know these things, we're trying to find all these things just by 2 small clues that were given. Okay, so let's have no radicals in the denominator when we do this. Okay, so if cosine equals 7/2, what does cotangent equal? So, or sorry, what in the world? I read that wrong. If cosine is 7/2 and cotangent is less than 0, find all these things. We will have to find cotangent, but that's not the only thing. Oh, and I see we have tangent 2 times here. That was a mistype. Sometimes I get carried away with copy and paste. So if cotangent is less than 0, that means that it's negative. So basically what we have to, the first thing we're going to want to do is graph the triangle, which is what we see all the way into the top right, because that will help us find the other things. So, but if we want to graph the triangle, we have to first figure out what quadrant it's in. So let's kind of draw like our quadrants right here, and we can rule out certain ones that we know it's not going to be in. Okay, well, cosine is 7/2. 7/2 is positive. So we know that if cosine's positive, cosine is positive in quadrant 4. But since all of them are positive in quadrant 1, it's also here. So we know that it cannot be in quadrant 2 or 3 because cosine is not positive in those. So it's got to be 1 or 4. But when looking that cotangent is negative because it's less than 0, all are positive in quadrant 1. So it can't be quadrant 1 because we found out something's negative in this problem. So it's going to be quadrant 4. Right? So now we're going to go over to right here, and we're going to graph the triangle. Okay. So let's have our axes, and we know we're going to be in this quadrant because we just figured that out. And what we do is we draw the hypotenuse out from the origin, so it would be kind of like that. And then our vertical side goes to the x-axis, so we draw it up like that. And think about it, if we were to draw all the other triangles, would that make like a butterfly? Yes, it would. And then our other side is going to be right here. Let me redraw that. So our right angle is going to be right here, and the angle we're finding is always going to be the one that's right here, that's close to the origin. Okay, but we found out, didn't we just, we found out that we know some of the side lengths of these if cosine is 7/2. So 7/2, let's think about it. Remember, we can use SOHCAHTOA. Okay, we're going to use the CAH part. So cosine, the cosine of an angle is going to be the adjacent side over the hypotenuse. Adjacent means the side that's close to the angle, but it's not the hypotenuse. So if this is our angle, our hypotenuse is this one, so that's not the adjacent side, so it's got to be this one. So we can already just write our letters. This is our adjacent side, this is our hypotenuse, and this is our opposite side. Opposite meaning that it's just opposite from the angle. And so if sine, or if cosine is 7/2, then 7 is our adjacent length. And our hypotenuse is 2. All right, that's not good. Why that's not good is because the hypotenuse is not going to ever be the shorter than any of the other sides. So that was a faulty problem that I made. Sorry about that. Let's fix that. That's not good. Let's just change it to 2/7. That doesn't change anything except for that what our A and H are. Okay. All right, so now we changed it. We're gonna erase that. Say 2/7. And erase that and erase that. So now our adjacent side is 2 and our hypotenuse is 7. But we need to know our opposite side to be able to find all the things we need to find. So we use a squared plus b squared equals c squared, or in this case, x squared plus y squared equals r squared. What is our x? Well, x is the horizontal one. I mean, technically it doesn't matter because we know our properties, but x is 2. And we're trying to find y. And our radius is the hypotenuse, which is 7. So we have 4, that would be 4 plus y squared equals 49. And we know how to solve problems by now. So we would find out that y is the square root of 45. But let's think about it. Since this is down and below the axis, that's going to have to be negative, isn't it? Because when we find that, we would get the positive and negative square root of 45, but we need to take the negative one because down is negative, and since it's below the y-axis or x-axis, sorry. And that's our sides. We find out that A is 2, H is 7, and O is negative square root of 45. So now we can find the other ones. We can't find the angles yet, so let's leave that alone. So, sine of an angle. Sine by using SOHCAHTOA. Let's just go ahead and write our lengths. This is what we found. All right, so by SOHCAHTOA, we would find out that a sine of an angle is going to have to be opposite over hypotenuse. So that would be negative square root of 45 over 7. Well, that's not really simplified, is it? Because this might be annoying to you, but think about it. I mean, we have square root of 45, and we can break down that radical. So how I would do this is just divide 45 by 4 and 9 to figure out what it can come out evenly, since 4 and 9 are perfect squares. 45 divided by 4, 11.25. Let's not do that. 45 divided by 9 is 5. 45 divided by 16, that's not something we want to use, or 25. So 9 times 5 equals 45. And this is definitely review. So that would give us 3 root 5. So, like, I'm not going through this that much because you should know how to do that. But this is the answer for sine of the angle. Now, cosine of the angle. Well, we don't really have to do much work, do we? Because we know that sine and I just said cosine, sorry, cosecant, CSC cosecant. We're looking at that now. We know that that's just flipped over because it's an inverse function, and cosecant is h over o. So we're just going to change that to 7 over negative 3 root 5. Oh, but guess what? We can't have a denominator in the, radical in the denominator. We can just change this back to 45 for now, because remember, that's what we already got right here. And remember how to do that is we'll just multiply by square root 45 on the top and bottom. And that would give us 7, and as we would figure out, that would be 3 root 5 times 3 root 5. And that would give us negative 45 on the bottom here. Then, so this is a lot of work. Whenever you have square roots, it's worse, but that's just what happens to be like in this one. So then that would be 7 times 3 is 21 root 5 over, oh, sorry, I just messed up something on here. Over 45, negative 45. And that is what it is. Oh, actually, let's think. Can 21 and 45 be simplified more? Actually, it can. So if you think about it, there was not really a point in changing this back to a negative 45, but because you would have had a 3 on there anyways. But 21 and 45 can both divide by 3. So that would give us 7. I just deleted the wrong thing, sorry. Okay, this is freezing up. 7 root 5 over 15. Okay, and there you go. So we would have gotten the same answer either way if we left this as 3 root 5, but whatever. So that is our answer, and it's simplified. So that one wasn't so fun, but let's see, cosine. Oh, yay. Why do I say yay? Because we were already given that one. Cosine is a over h, but we were already given that anyways. That was 2 over 7. Secant is just reversed of that. It is h over a, since it's the inverse, and we can just say 7 over 2. Those ones are pretty easy. Now, let's do tangent and cotangent. So to remember what our values were, we had h is 7, a is 2, o is negative square root of 45. Okay, so tangent is by SOHCAHTOA, we know o over a. So that's going to give us negative square root of 45 over 2. And remember, we already know how to simplify that. So you really only have to simplify once, because we already know that that's what it is. So that would be our answer. That's the most simplified it can be. Now, cotangent. That is A over O, which would mean 2 over negative 3 root 5, which is the same thing as negative square root of 45, as we already found. And that would give us, oh wait, so since that's a radical in the denominator, we can't do that. So we will multiply top and bottom by square root of 5. This is what I was saying we could have done for the cosecant. So that gives us 2 root 5 over, this becomes 5. So negative 3 times 5 is negative 15, and that is the most simplified we can have it as. And there you go. Those are all of our trigonometry and graphing, but we still have to find the angles, the normal angle and the reference angle. So let me move this down here just to remind you. So remember, this is what our graph kind of looked like. Where did I draw that? Okay, here it is. It looked like this. So this is going to be our reference angle. And our full angle is going to be all the way around, since it's a fourth quadrant angle. So what do we know about our values that they need to be? Our angle is going to have to be between 270 and 360 degrees. And our reference angle, well, we always know that has to be 0 to 90 degrees. So this will help us when finding our values. So I'm just going to write off to the side here. We're going to find our angle. And like we said, it needs to be between 270 and 360 degrees. How do we find it? Well, we were given that the cosine of our angle is 2 over 7. This is kind of like any normal algebraic equation. So think of it as like 2x equals 4. Our angles are x, cosine is 2, 2/7 is 4. So that, hopefully that doesn't confuse you, but all we know is that it's easy to find x. All we have to do is get rid of this cosine. But you might think divide by cosine, but that's not something you can do. What we actually have to do is take what the opposite of cosine is, which is to cosine to the -1, and you can get that on the calculator by, it's on right here. By the way, there is no cosecant, secant, or cotangent buttons. I don't know why I said that. So if you just have to know that they're opposites of each other, so you couldn't do that. Anyways, but we have to do that on both sides, and this would cancel out our cosecants or cosines. I'm getting mixed up now. So cosine to the -1 of 2/7 is what we need. So I have my calculator here. We're going to do second cosine. So that gives, oh, for some reason I have to turn on the calculator, even though this is a fake thing. And then we're going to type in 2/7. And remember that we're supposed to find our angle. Okay. What did we get? We got 1.28. That is odd, because didn't our angle need to be 270 to 360 degrees? So basically, whatever function you type in, it gives you something random. It's not really random, but to you it is, because you haven't learned it yet completely. But so it might not always give you your angle. In this case, this would actually be our reference angle, because it's between 0 and 90 degrees. So our reference angle, if we're rounding to, say, 3 decimals, 1.281 degrees. And what do we know about our angle is that it needs to be between 270 and 360 degrees. So we're going to have to do 360 minus the reference angle to find it, because that's the opposite of like, if you had the angle, then you would do 360 minus it to get the reference angle, remember? So if you don't understand that, please watch the previous videos. That would be 1.281. So basically, even if you don't remember specifically that you would have to divide or subtract from 360 in this case, you can just do anything with 360 or 180, and you would know if it's right or wrong, because we know it needs to be between 270 and 360. But that's right, because we get a value in between that, and that it means our angle is 358.719 degrees. All right, let's put this down here. I'm going to write it up here. Hang on a second. And remember, why we know that it had to be between 270 and 360 degrees is because it's in the fourth quadrant. All right, so I wrote it in there, and we see we have everything. And this is what our work looks like. And that seemed like it was a lot, but it's really not. It seemed like it because I had to explain. Well, it looks like, let me fix this in the cotangent. It's not a very good handwriting. Remember that was 2 square root of 5 over -15. So that's it for this video. Thanks for watching, and I'll see you on the next one. Thanks for watching.